Okay, problem number 3 on the first set, Monday's April 13th homework. Question, they tell us the derivative of a function. They tell us a functional value. First question says the function has a critical point at x equals 3. Does it have a minimum, a maximum, or neither? So we just need to check that. It's got a critical, this is the derivative, so clearly it has a critical point at 3 because it makes that 0. So what we would normally have done in these problems is make our little number line to the left of 3. That's a negative number, that's always positive, so it's negative, so that's positive, it's going to make it a minimum point. The AP board's pretty clear. Everyone uses this number line method. It pretty much gets taught everywhere. But that's not a justification. So when it says justify your answer, this becomes your justification. The reason I know it's a minimum point is because the derivative is going from negative to positive. That's all you got to do. You just got to say what that says, but they won't allow just that, so you got to say it in words. So it's a minimum point. Second problem says, when is the thing decreasing and concave up? We just did decreasing here, decreasing from 0 to 3. So now I got to do concavity. Concavity is second derivative. So the second derivative is the derivative of the first term, which is 1, times the second term, which is e to the x, plus the second term, which is e to the x, times the first term, which is x minus 3. So there's the second derivative. I want to find the critical points of the second derivative, so I set it equal to 0. I factored out at e to the x. Leaves me the 1 plus x minus 3 equals 0. Leaves me e to the x times x minus 2 equals 0, gives me a critical point at 2. Plug in a number to the left of 2. This is negative. To the right of 2, it's positive. So the question was concave up. It's concave up from 2 to infinity. So it's concave up from 2 to infinity. Decreasing from 0 to 3, they want to know when it's doing both. So it's doing both, just between 2 and 3. And the third part of this problem is basically just do an integral. It's a pretty straightforward problem for sure. Usually you see these problems in multiple choice, not so much in the written, because it's just a quicker thing. They gave us, again, the derivative. They told us f of 1 and 7, we got to find f of 3. So you got to take an antiderivative, find c, and then plug back in. So I just find, this is f prime of x, so I want to find f. Find the antiderivative of x minus 3 times e to the x. It's an integration by parts. So my u equals x minus 3, dv equals e to the x. Du is dx, v is e to the x, so I get uv, x minus 3 times e to the x, minus the integral of v du, or e to the x, which is just e to the x, so I wind up with e to the x times x minus 3, minus e to the x plus c. I know that f of 1 is 7, so I got to go back and find that c, pretty straightforward. So 7 equals, I'm just plug in 1 to this, so I get e, I get negative 2, I get e plus c, I wind up with c equals 3e plus 7. Which means my actual function is e to the x times x minus 3 minus e to the x plus my c, which is 3e plus 7. And the actual question was find f of 3, kind of a silly question at this point because we got everything else. So we just plug in that 3 for x, so we get e to the third, that's going to be a 0, that's gone. So you just wind up with e to the third plus 3e plus 7, or minus e to the 3 cubed plus 3e plus 7. Again, pretty straightforward problem. Pretty unusual to see a problem like this without all those little twists and turns because these are all kind of what I would call more like a multiple choice question. So that's it for the third one there.